When does an interaction become an observation in quantum physics? Have you ever wondered how something as simple as looking at an object can change its behavior? In the world of quantum physics, this idea takes on a whole new meaning. The question we are tackling today is, when does an interaction become an observation in quantum physics? In quantum physics, an observation is not about someone consciously watching something. Instead, it revolves around an interaction between quantum systems that leads to a change in the system's behavior or state. So, when does this interaction cross the line into observation? It happens when the interaction effectively measures or collapses the quantum system's wave function. This process transforms a superposition of possibilities into a definite outcome. At the heart of this concept is the wave function. This mathematical description of a quantum system contains all possible states that the system can occupy at once, known as superposition. When a quantum system interacts with another system, such as a measuring device or even the environment, this interaction can cause the wave function to collapse. This means the system settles into one specific state, which is what physicists refer to as an observation or measurement. A classic example that illustrates this is the double-slit experiment. In this experiment, particles like electrons behave like waves and create an interference pattern when they are not observed. However, if any interaction occurs that reveals which slit the particle passes through, such as placing a detector at the slits, this interaction acts as an observation. It destroys the interference pattern, causing the particle to behave like a classical particle instead of a wave. It is important to note that this observation does not require a conscious observer. Any physical interaction that extracts information about the quantum system counts as an observation. Even the tiniest bump between particles can qualify. This phenomenon is often referred to as decoherence, where the quantum system loses its delicate superposition due to interactions with its environment. So, in quantum physics, an interaction becomes an observation when it leads to the quantum system losing its superposition and producing a definite, measurable outcome. This strange and quirky feature of the quantum world challenges our everyday intuition. The mere act of interacting with a quantum system fundamentally alters its behavior. In practical terms, this means that scientists must design quantum experiments very carefully. They want to avoid unwanted interactions that would collapse the wave function too soon. This principle is essential for technologies like quantum computing and quantum cryptography. Maintaining superposition and entanglement without unintended observations is crucial for their success. In the realm of weird science, this means that reality at the quantum level is not fixed until it is observed through interaction. Even the smallest physical contact can count as an observation, collapsing possibilities into a single outcome in a way that seems almost magical compared to classical physics.